Hello, in this lecture we will find the value of 2 times AP of the size of 2 times AP. Okay, you can see in the picture triangle ABC, and size AB of the triangle is 90 units, size AC of the triangle is 70 units, and size BC is 50 units, and we also have a circle. The center of the circle is in point C, and point C is on side AB of the triangle, and also side BC or side CB of the triangle is tangent to the circle at point, we will call that point O. So side CB or BC of the triangle is tangent to the circle at point O, and also side CA of the triangle is tangent to the circle at the point that we will call that point point E. Again, side CA of the circle is tangent to side CA of the triangle is tangent to the circle at point E, and side CB of the triangle is tangent to the circle at point O, or the touching point of the side CB with the circle is point O, and the touching point of the side CA with the circle is point E. So from point C we have two tangents to the circle, tangent CE and tangent CO. Okay, so we will connect points P and C together. We also will connect points O and P together by a straight line. So as you can see from the drawing, from the picture, OP is the radius of the circle. I will mark it as R, abbreviation of radius, because actually the line exits from point P, the center of the circle, and touches the circle at point O. So it is defined as the radius of the circle. Okay, OP is the radius of the circle, and in the same way we will connect points P and E together by a straight line, and again PE is the radius of the circle. I will mark it as R because it exit, the line exit from point, or starts from point P, the center of the circle, and ends at point E on the circle. So it is defined as the radius of the circle. Okay, and as I've already told you, CE is tangent to the circle, and the touching point of the tangent with the circle is point E, and also CO is tangent to the circle, and the touching point of tangent CO with the circle is point O. And actually we have a rule that if you have a circle, and from external point of that circle, let's call it point V. Point V is external point of this circle because it is not inside the circle nor on the circle, so it is outside the circle, and for that reason point V is called external point for this circle. So if from point V we draw two tangents to this circle, let's call the touching point of this tangent with the circle F, and we'll draw another tangent to that circle, and let's call the touching point of this tangent with the circle L. Then VL equals to VF. Okay, again, if from external point of a circle you draw two tangents to that circle, then those two tangents are equal to each other. That is to say, VL equals to VF. Okay, so it is a rule that applies for all the circles in the world. If you have a circle and you have external point of that circle and you draw two tangents to that circle, then those two tangents are equal to each other. So VL equals to VF. Okay? Actually, we can implement this rule in our circle, because in our circle we have external point of that circle, that is to say point C is the external point for this circle, and from point C we actually draw two tangents to this circle. CE is the first tangent to this circle, and CO is also the second tangent to this circle. So from external point of this circle we draw two tangents to this circle, and according to the rule that I mentioned, these two tangents must equal to each other. So for that reason we can say that CE equals to CO, because those two tangents that are drawn from external point C for of the circle equal to each other. So we can write that CE equals to CO. Okay? If you draw from external point of a circle two tangents, those two tangents are equal to each other. So CE equals to CO. Okay? CE equals to CO, and actually, as I have already told you, PE is the radius of the circle, and PO is also the radius of the circle. So we can say that PE equals to PO equals to R. Okay, because both of these lines are radiuses of this circle. So we can say that PE equals to PO equals to R. So this line equals to this line. Both of them are radiuses of the circle. And of course, CP equals to itself, or PC, CP is the same. CP equals to CP. So actually we can say that three sides of the green triangle are equal to three sides of the black triangle. Because side CE of the green triangle equals to side CO of the black triangle. Side PE of the green triangle equals to side PO of the black triangle, because both of them are radiuses of the circle, and side CP of the green triangle is equal to side CP of the black triangle. Again, side CP of the green triangle is equal to side CP of the black triangle. So three sides of the green triangle are equal to three sides of the black triangle. So we can deduce from that triangle, the green triangle, the green triangle is congruent to the black triangle, or the green triangle, that is triangle CEP, is congruent to the black triangle, that is to say triangle COP. So triangles CEP and COP overlap to each other because three sides of the green triangle are equal to three sides of the black triangle. Okay? Again, CE of the green triangle equals to CO of the black triangle. EP of the green triangle is equal to OP of the black triangle, and CP of the green triangle is equal to CP of the black triangle. For that reason, the green triangle congruent to the black triangle or the green triangle overlap to the black triangle. Okay? And from the fact that the green triangle congruent to the black triangle, we can deduce that angle ECP of the green triangle is equal to angle OCP of the black triangle. Okay, so I write it down. So we can deduce that angle ECP of the green triangle equals to angle OCP of the black triangle. Okay, angle OCP equals to angle ECP according to the rule that one minute. Okay, angle ECP of the green triangle equals to angle OCP of the black triangle according to the rule that corresponding angles in congruent triangles, the green triangle congruent to the black triangle. So incongruent are equal to each other. Again, I repeat again, because of the fact that the green triangle congruent to the black triangle, we can deduce from it that angle ECP of the green triangle equals to angle OCP in the black triangle according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so if we call to angle ECP theta, then angle OCP will be also theta, because those two triangles are equal to each other. Okay, so I write it down. Angle ECP in the green triangle is equal to theta, and is also equal to angle OCP in the black triangle, that is also equals to theta. Okay, angle ECP in the green triangle equals to theta, and it equals to angle OCP in the black triangle, that is also equals to theta, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so I will draw again triangle ABC. So I draw again triangle ABC. P is the center of the circle, and as you can see here, angle BCP equals to angle ACP equals to theta. So actually here we can define line CP or PC is the same. We can define line CP as angle bisector. Why? Because it actually divides angle ACB to two equal angles. So actually angle ACB is divided to two halves. This is the one half of the angle ACB, and this is the other half of the angle ACB. So for that reason, PC is angle bisector, because it actually cuts angle ACB to two equal parts. Okay, for that reason, PC will be called as angle bisector. Okay, I will write it here. Or CP is the same. CP is angle bisector because it divides angle ACB to two halves. ACP is the first half, and the other half of angle ACB is PCP. Okay, for that reason, CP is angle bisector. It cuts angle ACB to two halves, or to two equal parts. For that reason, CP is angle bisector. So actually we have the angle bisector theorem The angle bisector theorem states that an angle bisector in a triangle divides the side that it hits in a ratio that equals to the ratio of angles sides. I will repeat again on the angle bisector theorem. On angle bisector theorem, the angle bisector theorem, an angle bisector in a triangle divides the side that it is in a ratio that equals to the ratio of angles sides. Okay, now I will explain in detail the meaning of the angle bisector theorem. An angle bisector, that is to say CP, as I have already told you, is angle bisector because it divides angle ACB to two halves. And this half of course equals to this half. Okay, so CP is angle bisector, and this angle bisector is in triangle ABC. Okay, the angle bisector CP in triangle ABC divides the side that it is. The angle bisector CP is side AB, and the theorem states that it divides the side that it is, that is to say, CP divides side AB in a ratio that equals to the ratio of angle sides. So it divides, CP divides side AB in a ratio that equals to the ratio of angle sides. And we relate to the angle that is divided by CP to two halves. So we relate to angle ACB. And the ratio and angle ACB actually consists of two sides, side AC and side CB. Okay, angle ACB consists of two sides, side AC and side CB. And the ratio between those two sides equals to AC over CB. So we can write that the ratio between the angles sides is AC over CB, because angle ACB consists of side AC and side CB, so the ratio between those sides is AC over CB, and that ratio is exactly the same as the ratio that CP divides side AB. And actually CP divides side AB to two parts, to part AP and part PB. And the ratio between those two parts is AP over PB. So actually this ratio AP over PB equals to the ratio of the angles sides, and the ratio of the angle sides is AC over CB. Okay, so AP over PB equals to AC over CB. Again, the angle bisector, that is to say CP, in a triangle ABC divides the side that it eats. CP eats side AB, and it divides it to two parts, AP and PB. And the ratio that it divides side AB is AP over PB. So AP over PB, this ratio is equal to the ratio of the angle's sides. We relate to angle ACB, its sides is AC and CB, and the ratio between the angle sides is AC over CB. So the ratio that CP divides AB, that is to say AP over PB, equals to the ratio of the angle's sides, that is to say AC over CB. Okay? So again, an angle bisector CP in a triangle ABC divides the side that it eats, that is to say divides side AB, and it divides side AB in a ratio that is equals to AP over PB, and this ratio is equal to the ratio of the angle sides. We relate to angle ACB, and the sides of angle ACB in the triangle ABC is AC and CB. So the ratio of this angle sides is AC over CB, and that ratio equals to the ratio that CP divides side AB, that is to say AP over PB. Okay? And it is true in every triangle that has angle bisector. I repeat again, angle bisector divides the angle to two halves. Of course, they are equal to each other, and actually it eats side AB, and the ratio it divides side AB to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the sides of ACB, of angle ACB. And angle ACB consists of two sides, side AC and side CB. So the ratio between those two sides, AC over CB, equals to the ratio that CP divides side AB, that is to say AP over PB, or AP over PB equals to AC over CB. Okay? Again, the angle sides, we relate to the angle that is divided to two halves. So we relate to angle ACB, and the ratio between angle AC consists of side AC and side CB, and the ratio between those two sides, that is to say AC over CB, equals to the ratio that CB divides side AB. That is to say AP over PB, or AP over PB equals to AC over CB. Okay, so I will write again the equation from the angle bisector theorem. I will mark it as equation 1. AP over PB equals to AC over CB. We know that from the question itself that AB equals to 90 units, and AC equals to 70 units, and CB equals to 50 units. It is given us in the question. Okay, so AB equals to 90 units, AC equals to 70 units, and CB equals to 50 units. So this is the first equation that is actually the angle bisector theorem. Here we can define AP as X. AP equals to X. So BP equals to AB minus AP. Okay, BP or PB equals to AB minus AP. So PB equals to 90 minus X. So I will write it here. AP equals to X and PB equals to 90 minus X. Okay. AP equals to X and PB equals to 90 minus X. So we can substitute in the first question, in the first equation, we can substitute AP by X and PB by 90 minus X. Okay, so let's do it now. X over 90 minus 6 equals to AC over CB. So I substituted AP by X because AP equals to X, and PB by 90 minus 6 because PB equals to 90 minus 6. Now, as you can see here, AC equals to 70 and CB equals to 50. I will write it here. AC equals to 70 units and CB equals to 50 units, so we can substitute in this equation AC by 70 and CB by 50. Okay, we substituted AC by 70 because AC equals to 70 and CB by 50 because CB equals to 50. Now 70 equals to 10 times 7 and 50 equals to 5 times 70 equals to 7 times 10 and 50 equals to 5 times 10. So we write it here. Okay, 70 equals to 7 times 10 and 50 equals to 5 times 10. So we can substitute 70 by 7 times 10 and 50 by 5 times 10. Okay. Okay, substitute 70 by 7 times 10 and 50 by 5 times 10. Now we have 10 in the numerator and 10 in the denominator, so we can cancel 10. Or we can reduce the numerator and the denominator by 10 because we have them in the numerator and the denominator, so we can cancel 10. And after the cancellation of 10, we will get that x over 90 minus 6 equals to 7 over 5. Okay, here we cancel 10 in the numerator and in the denominator. We got that x over 90 minus 6 equals to 7 over 5. Now we can multiply the equation by 5, or we can multiply both sides of the equation by 5. So we multiplied both sides of the equation by 5. 7 divided by 5 times 5 is 7. And x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Okay. Now we can multiply both sides of the equation by 90 minus 6. Actually, it is allowable to multiply both sides of the equation by 90 minus 6 because x is, as you can see, x equals to AP. X equals to AP and x is less than 90 because AB equals to 90 units. So x is less than 90, so 90 minus 6 will be a positive number. So it can never be 0. For that reason, we can multiply both sides of the equation by 90 minus 6, okay? So we multiply both sides of the equation by 90 minus 6. 7 times 90 minus 6 equals to 7 times 90 minus 6. And 5x divided by 90 minus 6 times 90 minus 6 equals to 5x. Now we will open the brackets. So we open the brackets. 7 times 90 equals to 630. And 7 times minus 6 equals to minus 7x. Now we will add 7x to both sides of the equation. So we added 7x to both sides of the equation. 5x plus 7x equals to 12x. 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. So 2x divided by 6, 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. But we also know that AP equals 2x. AP defined it is equals 2x, okay? Here AP equals 2x. AP equals to x, so 2 times AP equals to 2 times x. So AP equals to x, so 2 times AP equals to 2 times x. So 2 times 6 equals to 105, and 2 times 6 equals to 2 times AP. So we can write that 2 times x also equals to 2 times AP. Okay? Two times 6 equals to 105. But 2 times 6 equals to 2 times AP, so we can add equals to 2 times AP. Okay, so here we have 2 times 6 equals to 105, and here 2 times 6 equals to 2 times AP, so we can add the 2 times 6 equals to 2 times AP. So we got that 2 times AP equals to 105. Okay, so I write it now. (105 units). Okay, so actually this is the answer to the question. Two times AP from here equals to 105 units. I will add 105 units. So the value of 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. Actually, we wanted to find the value of 2 times AP, and we have a triangle ABC. AC equals to 70 units, CP equals to 50 units, and AB equals to 90 units. And we have a circle that its center is P, and side AC of the triangle is tangent to the circle at point E, and side CB of the triangle is tangent to the circle at point O. So we have a rule that if from external point of a circle you draw 2 tangents, then those 2 tangents are equal to each other. In this picture, VL equals to VF, so we can implement this rule in our circle. We can say that CE equals to CO, and also PE equals to PO, and PC equals to itself. For that reason, 3 sides of the green triangle equals to 3 sides of the black triangle. Therefore, the green triangle is congruent to the black triangle, and from that we can deduce that angle ECP in the green triangle equals to angle OCP in the black triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. So we marked angle ECP as theta, and so angle OCP must be also equal to theta. And I draw a triangle ABC again. This is triangle ABC. Actually, PC is angle bisector because it divides angle ACB to 2 equal parts, or to 2 halves. This is the first half, and this is the second half. So for that reason, according to the angle bisector theorem, if you have in a triangle like triangle ABC an angle bisector that splits angle to 2 halves, then this angle bisector CP actually divides the side that it hits, that is to say side AB, to 2 parts, and the ratio between those 2 parts, that is to say AP over BP, equals to the ratio between the angles sides, that is to say AC over CB, or again AP over BP, the ratio that angle bisector CP divides side AB equals to the ratio between the sides of angle ACB, that is to say AC over CB equals to AP over PB. Then we marked we defined AP as x, and so PB will be 90 minus 6. So we substituted AP by x and PB by 90 minus 6, and AC by 70 and CB by 50, because it is given us in the question, this data, and we arrived that to the solution of that 2x equals to 105 units. So that is to say 2 times AP equals to 105 units. Okay, thank you very much.